Welcome everyone to the Inside Java Newscast, where we cover recent developments in the OpenJDK community. I'm Nicola Parlock, Java Developer Advocate at Oracle, and tonight we're going to talk about the JDK's path towards a JSON API. This is based on an email that Paul Sandoz, probably best known for being the lead of Project Babylon, sent to the Core Libs dev mailing list back in May. That means we don't even have a JAP draft yet, so all of this is very early, and this episode is more about the big picture than about details. Ready? Then let's dive right in. Boy, I'm happy this take worked. Let's start with why. Why does the JDK need a JSON API? It's decidedly not because there's a lack of JSON libraries in the ecosystem. Not only are there plenty, many of them are doing a really great job. No, the motivation comes from the overlap of two facts. First, JSON has become a universal and omnipresent data interchange format. And second, the JDK has a batteries included philosophy which aims to provide all building blocks needed to write basic programs. Taken together, the JDK wants developers to be able to write basic programs without having to rely on third-party dependencies. And nowadays that means it needs to be able to effortlessly handle JSON. But that also means that this API is not meant to once and for all solve the JSON problem, to cover every use case and in the process make all those existing projects superfluous. No, it aims to sit on the other end of the spectrum, be simple to use for parsing, traversing and generating conformant JSON documents, and leave more advanced features like data binding or path-based traversal to third-party libraries. Performance should be good enough, but will be less important than simplicity. JSON can be described by what's called a railroad diagram, which shows how to construct it via subtyping and composition, or sums and products, or algebraic data types, or data-oriented programming. Yes, it's not all the same, but here it's close enough. So we need to model a value with possible expressions like array, object, and number. And after everything I've learned and said about data-oriented programming in recent years, I would expect this to be a sealed interface with record implementations, but annoyingly, it's neither. While that approach is a perfect fit, the lack of encapsulation makes internal evolution behind a stable API tricky. In many situations, that's no big issue, but for a public JDK API, it does matter. So, to my dismay, the idea is to use interfaces with hidden implementations. At the top, there would be JSON value, extended by JSON array, JSON object, JSON string, JSON number, and so forth, each with an accessor method like values, members, value, etc. To get instances of these classes, you could call a parse method with a JSON string that then returns a JSON value. Alternatively, static factory methods can create them from the Java type they contain. For example, a JSON array from a list, a JSON object from a map, or a JSON string from a, you guessed it, string. Either way, once you have JSON values in hand, the only two mechanisms to interact with them are type checks and accessors, both presumably as part of pattern matching. Paul gives an example for how this API can be used to safely traverse a JSON document. Given a simple JSON object, we may want to ask whether it has name and age properties and whether the age fits into an int. And if so, extract said properties into string name and int age variables. Because the JSON types are interfaces and not records, and maps and lists don't interact with patterns yet, the condition that verifies all that is a bit bulky at the moment. But once we get deconstruction patterns, it shrinks down to if the parsed document is an instance of JSON object with var members, and members get name is an instance of JSON string with var name, and members get age is an instance of JSON number with int age, then we're happy and can use name and age. Paul writes, so over time, as more pattern matching features are introduced, we anticipate improved use of the API. This is a primary reason why the API is so minimal. Convenience methods we add today, such as a method that accesses a JSON object component as, say, a JSON string or throws an exception, will become redundant in the future. An example of that can be seen in the way the API handles numbers. The JSON specification makes no explicit distinction between integral and decimal numbers, nor specifies limits on the size of those numbers. Which means Java code does not generally know what Java type best fits a JSON number string representation. This API deals with that by making JSON number parse to the Java number subtype that best fits the string, and then letting the user apply pattern matching to limit what type she's willing to process. That indeed makes this API very minimal, to the point where it hardly has any API. And that doesn't come without criticism. Woo! Apparently, night's over. The reason why Paul wrote this email is that Project Babylon developed a variant of this API for its internal experiments Unrelated to JSON, but yeah, it is omnipresent. So they've been working with this for a while, and Paul describes it as a pleasure. They were able to quickly write code to ingest and convert, and the out-of-box experience has so far been positive. The prototype implementation is located in the JDK Sandbox repository under the JSON branch, which I link in the description, together with the just as prototypical Java doc. It passes all applicable conformance tests of the unofficial but well-established JSON test suite, and performance is good when compared to other JSON implementations, even though not a lot of optimizations have taken place yet. So, all good? JDK enhanced proposal when? Not so fast. This API has only been exposed to a few real-life use cases, and as I alluded to a minute ago, not everybody is happy with the very minimal, very pattern-matching heavy design that makes some common tasks more cumbersome than a simple method would. That seems particularly true when it comes to behavior like try to access this as an instance of that type, or throw a helpful exception if it doesn't work, which is necessary to handle messy real-world use cases. And it's not like Java's future pattern matching features are all already settled, so that adds some uncertainty to this design too. I think it's safe to say that this will brew a little longer before it turns into a JEP, which might be a new one or an update of JEP 198, by the way. But once that happens, we'll of course cover it here. I'll see you then, or better yet, in 2 weeks. So long! Whew! Time to have breakfast, I guess.